Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at probability and complements. You probably already know that probability is the assigning to random events a number between 0 and 1 to indicate how likely it is to occur. Events with probability 0 are impossible. Probability 1 means they're certain. Events with low probability close to 0 are unlikely to occur. Events with a probability close to 1 are likely to occur. So giving a number to these random events allows us to compare events, allows us to see which is more likely. So in probability, we look at random events, events whose outcome is determined, at least partially, by chance. We're not interested in finding the probability that, say, I wear blue tomorrow, because that's not random. I choose and control the outcome. But we are interested in finding the probability of an event whose outcome isn't controlled, whose outcome is determined by chance. So the formula for probability is this. This says the probability of an event is the number of ways the event can occur over the total number of outcomes. We write it as NS. This means number in the sample space. Now note that you can only use this formula when all of the possible outcomes are equally likely. So if we know the probability of an event, we can find the probability of its complement. So what do I mean by complement? Well, if A is an event, A dash, its complement, is just that event not happening, kind of like the opposite. So the complement of rolling a 3 on a die is not rolling a 3 on the die. The complement of it raining today is that it doesn't rain today. So just as percentages add to 100%, probabilities add to 1. For that reason, if you know the probability of an event, the probability it does not happen is just 1 minus the probability it does. So if there's a 0.3 probability that it will rain today, there's a 0.7 probability that it will not rain today. All right, let's use this to answer some questions. So let's say I roll a normal 6-sided die. We let O be the outcome that I roll an odd number, P the outcome that I roll a prime number. So let's calculate probability of O. Well, when you roll a die, there are 6 outcomes, all of which are equally likely, so I can use this formula. So the probability of rolling an odd number, there are 3 odd numbers on the die. There are 3 ways this can occur. I can get a 1, a 3, or a 5 out of 6 outcomes in total. So whenever you're writing a probability, it must be a number between 0 and 1. It can be a fraction, decimal, or percentage. If it's a fraction, just make sure it's simplified. So you can write it as a half, 0.5, 50%, all are good. So what's the probability I roll a prime number? Well, again, there are 3 prime numbers, 2, 3, and 5, out of 6 outcomes in total, so that's a half. So probability of O and P, that means I roll a number that is both odd and prime. Well, there are 2 such numbers, 3 and 5, out of 6 in total. So 2 over 6 is 1 over 3. It's much easier to write this as a fraction, 1 over 3, than write 0.3 recurring. But again, you can write it as fraction, decimal, or percentage. What about the probability of O or P? The probability I roll an odd number or prime. Now, in maths, or written like that is an inclusive or. What does that mean? That means we are including all odds, all primes, or anything that's both. What I really mean here is, what is the probability I roll a number that's odd, prime, or both? So when we have or, we don't mean just one or the other. We mean the first one, the second one, or both. So how many numbers on the die are in that category? Well, we have 1 because it's odd, 2 because it's prime, 3 because it's both, 5 because it's both. There are 4 such outcomes out of 6 in total, which of course simplifies to 2 over 3. So what about this one? This says the probability or P complement. This is saying what's the probability I roll a number that is not odd or prime. That means it's neither odd nor prime. a number that's not odd and also not prime? Well, this one's actually pretty easy because of our previous answer. If I know that the probability of an event occurring is 2/3, the probability it doesn't occur is 1 minus 2/3, which is simply 1/3, and that's just common sense. All right, let's now look at a question involving the sum of probabilities. So in this question, we are told that a bag contains Mars bars, Crunchies, Moros, and Violet Crumbles, all of which are chocolate bars, if you didn't know. We're asked to calculate the probability of V complement. So we're asked that if we select a chocolate at random from this bag, that we don't get a Violet Crumble, we get something other than that. So how are we going to go about that? Well, we're told the information that the probability of a Mars bar is 3/8. That means that 3/8 of the chocolates are Mars bars. So the probability of its complement is 5/8. If 3/8 of the chocolate are Mars bars, 5/8 are not Mars bars. What that means is Violet Crumbles, Moros, and Crunchies make up 5/8 of the chocolates in this bag. Now this line says that each of these has equal probability. So there's the same number of Violet Crumbles, Moros, and Crunchies. So how are we going to figure out what each of these is individually? Well, we know the probabilities have to add to 1, so we know that this plus this plus this has to equal 5/8, because 5/8 plus 3/8 equals 1. So each of them will be equal to 5/8 divided by 3. So the answer I get there is 5/24. That means the probability of picking a Violet Crumble is 5/24. Similarly, the probability of picking a Moro is 5/24. Probability of picking a Crunchy is 5/24. So that means that the probability that I do not pick a Violet Crumble, the probability I pick something other than a Violet Crumble, is just 1 minus 5/24. If I know the probability something happens, the probability it doesn't happen is just 1 minus the probability it does. And 1 minus 5/24 is just 19/24. Alright, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.